An expression which involves at least one irrational number is called a surd. So let's write down the definition. An expression which involves at least one irrational number is called a surd. For example, under root 3 plus under root 2. Now both of these numbers, under root 3 is irrational and under root 2 is irrational. So their sum is also irrational number. In the next number, 3 minus 2 under root. Now 3 is a rational number, but under root 2 is irrational number. So whenever we take a difference of rational and irrational number, the answer is always going to be irrational number. So this is also a surd. The product of a rational number 5 and an irrational number 2, that is also an irrational number. So it's another example where we multiply a rational number with irrational number. It results in irrational number, but this is called surd. So all these three terms and quotient of two irrational numbers like under root 5 over 7, that's also irrational, but all these numbers are called surds. There is classification of surds that if y nth root of y, if nth root of y is an irrational number, then it is called surd of order n. So if nth root of y is an irrational number, then it is called a surd of order n. So what is called a binomial surd? An expression consisting of two terms, an expression consisting of two terms in which at least one is irrational is called binomial surd. And third type of surds, which are called conjugate binomial surds, are, take an example of under root 3 minus under root 5, or if we define if the product of two binomial surds is a rational number, then they are called conjugate binomial surds. conjugate binomial surds. And the example is if you have under root 3 minus under root 5 and under root 3 plus under root 5, then what would be their product? This is under root 5. So the product would be under root 3 minus under root 5 into under root 3 plus under root 5. If you remember from algebra this formula that a minus b into a plus b is equal to a square minus b square. Similarly, if we use that formula here, this would give us under root 3 whole square minus under root 5 whole square. So this would give us 3 minus under root 5 square would give us 5. The answer would be minus 2, which is a rational number. So this under root 3 minus 5 under root and under root 3 plus under root 5, they are called conjugate of each other, but they are both are called conjugate binomial surds. And we are going to learn a technique called rationalization. Let's do one question. Write 1 over 4 plus under root 7. Now the denominator contains under root 7, which is a rational number. We are going to write 1 over 4 plus under root 7 in a form which has no radical sign, in the denominator. Now this technique is called rationalization. Rationalization is a very good technique that we use in algebra to simplify algebraic expressions. And the way this technique works is that in the denominator, if we have a radical sign, then we read the sign which is in between those two. This is positive sign. So we will multiply solution. The way we will do it is, if we want to use rationalization technique, we will do it like this. We write the expression as such, and then in the denominator, look over the sign. We change the sign and we multiply with the expression 4 minus under root 7 over 4 minus under root 7. Nothing else changes. So all what changes is this middle sign here. And then we multiply and divide with the same expression. What happens here is that this becomes 4 minus under root 7 times 1. 1 is a multiplicative identity. It doesn't change anything. In the denominator, if you look, the formula which I just mentioned, a minus b into a plus b equal to a square minus b square, this formula is at work. In the denominator, we have two binomial surds which are conjugate to each other. Therefore, their product, we take their product, that is 4 plus under root 7 into 4 minus under root 7. This will give us 4 minus under root 7 over What is a in this case? 4. So a square, that is 4 square, minus under root 7 square. So this will give us 4 minus under root 7 over 16 minus 7. The answer would be 4 minus 7 over 16 minus 7 would be 9. Or we can write this. This is the answer, and you can see that the denominator doesn't have a radical sign. That was exactly the requirement of the question. And we are going to do another question here to better learn this technique. So the question would be, if x is equal to 4 minus under root 15, if x is equal to 4 minus under root 15, then find the following. What? We want to find out what is 1 over x. We want to find out what is x plus 1 over x. We want to find out what is x minus 1 over x. We want to find out what is fourth, x plus 1 over x whole square, and we want to find out what is x minus 1 over x whole square. And sixth part, we want to find out what is x square plus 1 over x square, and we also want to find out, as seventh part, x square minus 1 over x square. So we will make extensive use of this rationalization technique and see how we find all these quantities. Let's get started. Our question is, x is given equal to 4 minus under root 15. In order to find out 1 over x, if we reciprocate both sides, we will get 1 over x equal to 1 over 4 minus under root 15. And if we use the rationalization technique, we definitely can multiply. As long as we multiply and divide with the same number, it doesn't change the quantity. And for rationalization, you remember that we need to change this sign and then multiply and divide the quantity with the same number. So this is 4 plus under root 15 and 4 plus under root 15. In fact, we are multiplying the conjugate binomial surd of 4 minus under root 15. So what is a conjugate binomial surd of 3 minus 4 2 under root? The conjugate would be 3 plus under root 2. So we simply are multiplying and dividing with the conjugate binomial surd for using the technique of rationalization. So here, let's call this as 1 because we're going to recall this again. So 1 over x would be equal to 1. Now the multiplication of numerator with numerator and denominator with denominator, 1 is multiplicative identity, so this is going to be 4 plus under root 15 over 4 minus under root 15 times 4 plus under root 15, which is, we're going to use the same formula, a minus b into a plus b equal to a square minus b square. So this would give us 1 over x equal to 4 plus under root 15 over 4 square minus under root 15 square. Now 1 over x is equal to 4 plus under root 15 over 16 minus 15. This gives us 1 over x equal to 4 plus under root 15. 16 minus 15 is 1, which we don't write, and let's call this as equation number 2. We already have 1 here. If we add both of them, so 1 is 4 minus under root 15 and 2 is 4 plus under root 15. So adding 1 and 2, adding equation 1 and 2, we have x equal to 4 minus under root 15, and in 2 we have 1 over x equal to 4 plus under root 15, and when we add both of them, this will get cancelled and we'll be left with x plus 1 over x on left side is equal to 8. So this gives us our two of our answers are solved. In equation 2 we answered our question 1. We needed to find out 1 over x, which we have found in as part of number 2, and in this one we again have found out x plus, this is number 3, so x plus 1 over x is equal to 8, and now you want to find out what is x minus 1 over x. So x minus 1 over x is equal to, what was the value of x? That was 4 minus under root 15 and minus, what is value for 1 over x? That's 4, oh this is plus, this is 4 minus under root 15, and now if we simplify 4 plus under root 15 and then minus will change the sign inside, minus 4 and then plus under root 15. So this will give us x minus 1 over x equal to, 4 will get cancelled with minus 4, so this will give 2 time under root 15. So this is value of number 3 here. Our question number 3 has been solved as well. And now if we want to find the answer number 4 and number 5, we can take square. We already have found what was x plus 1 over x and x minus 1 over x. That's 2 times under root 15, and x plus 1 over x we have found out, that is 8. So taking square on both sides, squaring both sides, this is x plus 1 over x whole square is equal to 8 whole square. So this is x square. This formula here is a square plus 1 over x square plus 2 times x times 1 over x is equal to 64. That is the formula we are using, is a plus b whole square is equal to a square plus b square plus 2ab. So now you can see x will cancel with itself, and we will be left with x square plus 1 over x square will be equal to 64, and this 2 will go on the other side. This will be x square plus 1 over x square equal to 64.